deep within each of us lies a universe of staggering complexity, the human brain. Weighing merely 3 pounds, it orchestrates our every thought, emotion, and action. It's the seat of consciousness, the archive of our memories, and the engine of our imagination. Despite centuries of inquiry, this intricate organ remains the ultimate frontier of scientific exploration, an enigma that continually challenges our understanding of what it means to be human. How does a collection of cells give rise to the subjective experience of life itself? At its core, the brain is an astonishing biological supercomputer, comprised of approximately 86 billion neurons. Each neuron, a microscopic processing unit, forms intricate connections, synapses, with thousands of others, creating a network so vast it dwarfs any human-made system. These electrical and chemical signals flowing across synapses are the very language of thought, translating raw sensory input into rich perceptions and complex behaviors. It's a symphony of microscopic interactions that defines our reality, an intricate dance that never ceases. Perhaps the brain's most profound achievement is the emergence of consciousness, that elusive sensibi. It's the continuous narrative we construct about ourselves and our place in the world, the internal monologue, and the subjective experience of being alive. While scientists can pinpoint areas associated with self-awareness, the precise mechanism by which a physical organ generates this intangible sense of self remains one of the greatest unsolved mysteries. We are, in essence, our brains experiencing themselves, continually shaping our unique identity. Our past is not merely stored, it is actively constructed and reconstructed by the brain. Memories are forged through intricate patterns of neural activity, strengthened over time through processes like long-term potentiation. From the vivid snapshots of episodic memory to the facts of semantic memory, the hippocampus acts as a crucial gateway, translating fleeting experiences into enduring recollections. This complex process allows us to learn, adapt, and build upon our experiences, defining who we are and what we know. Yet, memory is not a perfect recording. Each retrieval is a creative act, subject to influence and distortion, making it inherently fallible. What we recall can be subtly altered by new information, current moods, or even the act of remembering itself. This reconstructive nature, while sometimes leading to inaccuracies, is also what allows our memories to remain flexible and adaptive, helping us integrate new experiences with old. Understanding this fragility helps us appreciate the intricate dance between past and present. Emotions, far from being mere subjective feelings, are deeply rooted in our brain's ancient structures. The limbic system, particularly the amygdala, acts as the brain's alarm system, processing threats and generating rapid emotional responses like fear and anger. These primal reactions are critical for survival, guiding us away from danger and towards safety. They are the quick, instinctive drivers that often precede conscious thought, shaping our immediate interactions with the world and ensuring our most basic needs are met. However, our emotional life is not solely driven by instinct. The prefrontal cortex, the brain's executive control center, plays a crucial role in moderating and regulating these raw emotional impulses. It allows us to pause, reflect, and choose our responses, rather than simply reacting. This sophisticated interplay between ancient emotional centers and newer cognitive regions gives us the capacity for empathy, complex social behavior, and self-control, enabling us to navigate intricate social landscapes with nuance and foresight. Every moment, our brains are bombarded with vast amounts of sensory data, sights, sounds, smells, tastes, and touches. Yet, we don't passively receive reality, our brain actively constructs it. It filters, interprets, and organizes this incoming information, creating a coherent, personal model of the world around us. This intricate processing happens at lightning speed, allowing us to interact seamlessly with our environment, often without conscious awareness of the millions of calculations occurring behind the scenes. Our perception is our unique creation. Ironically, the very mechanisms that allow our brains to create a coherent reality can also lead us astray. Optical illusions, auditory tricks, and cognitive biases demonstrate how our brains fill in gaps, make assumptions, and take shortcuts, sometimes leading to perceptions that diverge from objective reality. These illusions are not failures but rather insights into the brain's predictive and pattern-seeking nature. They reveal that what we see and hear is not just a reflection, but an interpretation, shaped by our internal wiring and past experiences. Beyond sensory deceptions, our brains are also prone to systematic errors in judgment, known as cognitive biases. These mental shortcuts, or heuristics, allow for rapid decision-making but can lead to irrational conclusions. From confirmation bias, where we favor information that aligns with our existing beliefs, to the anchoring effect, which overemphasizes initial information, these biases subtly influence our daily choices, often without our awareness. Recognizing them is the first step towards more rational and objective thinking, allowing us to challenge our default settings. The brain's response to stress is a powerful, evolutionarily conserved mechanism designed for survival. When faced with a perceived threat, the fight-or-flight response floods the body with hormones like cortisol and adrenaline, preparing us for immediate action. While vital for acute dangers, chronic exposure to stress can have detrimental effects on the brain. Prolonged cortisol elevation can impair memory, reduce neurogenesis, and even alter brain structure, demonstrating the profound link between our psychological state and physical brain health. The brain's intricate development from conception through adolescence is a miraculous orchestration, but also a period of vulnerability. Disruptions during critical windows can lead to neurodevelopmental challenges, impacting learning, social interaction, and emotional regulation. Conditions like autism spectrum disorder and ADHD often stem from differences in brain wiring and connectivity. Understanding these developmental trajectories is key to early intervention and support, helping individuals navigate a world not always designed for their unique neurocognitive profiles. When the brain's delicate balance is disrupted, the consequences can be profound. Mental health disorders, from depression and anxiety to schizophrenia, are not character flaws but complex conditions arising from a combination of genetic, environmental, and neurological factors. They involve imbalances in neurotransmitters, altered brain circuitry, and structural changes. The ongoing challenge for neuroscience is to unravel these intricate mechanisms to develop more effective and personalized treatments, moving towards a future of greater understanding and compassion for those affected. As we age, our brains undergo natural transformations. While some cognitive functions may decline, such as processing speed or certain aspects of memory, the aging brain also demonstrates remarkable resilience and adaptation. However, neurodegenerative diseases like Alzheimer's and Parkinson's pose significant challenges, gradually eroding cognitive abilities and motor control. Research into healthy aging and the prevention of these devastating conditions is a critical frontier, seeking to maintain not just lifespan, but also health span, the period of healthy, high-quality living. One of the brain's most hopeful characteristics is its extraordinary neuroplasticity, the ability to reorganize itself by forming new neural connections throughout life. This inherent flexibility means the brain is not static but constantly adapting and changing in response to experience, learning, and even injury. Whether mastering a new language, recovering from a stroke, or forming new habits, neuroplasticity is the biological basis for growth and transformation. It reminds us that our potential for learning and adaptation never truly diminishes. Harnessing neuroplasticity is at the forefront of modern therapeutic interventions. Techniques like cognitive behavioral therapy work by guiding the brain to form new, healthier thought patterns, essentially rewiring dysfunctional circuits. Rehabilitation after brain injury relies on targeted exercises to encourage unused neural pathways to take over lost functions. This remarkable capacity offers immense hope for recovery, learning, and personal growth, proving that the brain's resilience is a profound resource we are only beginning to fully understand and utilize. Far from being a passive state, the sleeping brain is incredibly active, engaging in vital processes crucial for our well-being. During sleep, memories are consolidated, emotional experiences are processed, and the brain performs essential housekeeping, clearing metabolic waste products. Different sleep stages, particularly REM sleep, are linked to creativity and problem solving, offering a unique window into our subconscious. A good night's sleep is not a luxury, but a fundamental biological necessity for optimal brain function and mental clarity, a time for the brain to reset and rejuvenate. Dreams, those vivid, often bizarre narratives of our sleeping minds, have captivated humanity for millennia. From ancient prophecies to Freudian interpretations, their meaning remains debated. Are they merely random firings of neurons, a byproduct of brain activity, or do they hold profound psychological significance, a symbolic language from our subconscious? Regardless, dreams highlight the brain's continuous imaginative capacity, even when we are unconscious, reminding us of the deep, mysterious wellsprings of human experience that lie beneath the surface of conscious thought. The quest to understand the brain is accelerating, driven by groundbreaking technologies. Advanced neuroimaging techniques like fMRI and optogenetics allow us to visualize brain activity with unprecedented detail. Brain-computer interfaces are beginning to offer new possibilities for those with paralysis, enabling thought to control external devices. Artificial intelligence is helping us model brain function, pushing the boundaries of what we can simulate and understand. These frontiers promise not only deeper insight but also innovative solutions for neurological and psychiatric conditions, transforming our future. As our understanding and capabilities grow, so do the ethical considerations. The ability to peer into, and potentially modify, the brain raises profound questions about privacy, identity, and the very definition of what it means to be human. Who controls brain data? What are the implications of cognitive enhancement? These are not merely scientific questions, but societal ones that demand careful consideration and public dialogue. Navigating these ethical horizons responsibly will be crucial as we continue our odyssey into the most complex and wondrous object known to us.